AcePhysics.org, Math and Physics Tutoring with Dr. Hudis.
When I was a sophomore in college, I took a class called Classical Dynamics of Particles and Systems. It's also known as Classical Mechanics, and the book that I used was this book here. This is a standard textbook on the subject. It's written by Marion and Thornton. It's an advanced book, especially for a sophomore level class. And I had taken or was currently taking most of the mathematics covered in the book, namely calculus, vector calculus, and linear algebra. But this was the first physics class that I took that relied heavily on mathematics as a language to describe nature. In fact, I can remember at one point during the semester, I was working with the equation for the damped harmonic oscillator, mx double dot equals negative kx plus cx dot. And it occurred to me that that was not just a differential equation to be solved, but it had a meaningful representation of something in nature, namely a mass moving back and forth on a spring with some damping. And although that concept, I've been working with physics now for so many years that I take that for granted, that these equations, they're not just math equations that need to be solved, they have meaningful pictures that go with them, meaningful physical, when you see an equation, you have to take that equation and translate it into the meaningful physics behind it. But at the time I was very excited about that, and I can remember for the whole night I was really excited about that idea. So I worked really hard in the class. The professor was very demanding. I spent a long time working on the homeworks and going to office hours or problem solving sessions. But at the end of the semester, after the final, I got a B in the class. I remember, I knew that I couldn't really solve most of the problems in the book on my own. And I remember thinking to myself, wow, if I could really get this book, that would be incredible. And I wasn't discouraged, which is kind of surprising, after taking a whole semester of a subject. And it was at the beginning of my physics career. It was maybe the third or fourth physics class I'd ever taken in my life. So I'd taken the whole subject, and I did not really understand or was able to solve most of the problems in the book, but I didn't feel discouraged. I just felt kind of like in awe of what it would be to learn it. And I wondered, wow, I wonder if I'll ever really be able to get this book. And when I say get it, I mean to be able to read through it with relative ease, understand all the equations, and be able to solve most of the problems on my own without help, and of course understand the majority of the concepts in the book. Since then, I've taken a graduate course on the subject using this book. This is another famous book, a more advanced book than that one, called Classical Mechanics 3rd edition by Goldstein, Poole, and Sofko. And now I'm proud to say that I get this book. I can solve most of the problems on my own. I can read through, turn to just about any page and understand what it's saying and understand the equations. And that's it's a great lesson that I learned.
Hello, I'm Dr. Jacob Hudis. If you need math or physics tutoring, please go to my website, AcePhysics.org, and book a lesson.
Because now when I'm in a graduate class and I don't understand something, or I'm stuck on something, I understand that that's part of the process. That feeling of not understanding it and being stuck, that just goes along with learning physics. That's what learning physics is. And with time and hard work and continual banging your head against the wall and just trying over and over again, eventually it makes sense. And so now whenever I'm stuck with something, I know that if I keep working, eventually I will get it. And this is just the process of learning physics. That's what learning physics is. It's if you want to lift weights and get strong, You go to the gym and you lift weights and it's very painful. It's hard to go in there and lift weights. And after a really hard workout and you really pushed yourself, the next day you might be sore, but you're not bigger and stronger. It takes time. And in a similar fashion, you go and you work really hard and try to learn physics, and it doesn't come right away. And sometimes it doesn't even come by the time the class is over. It may take several years of continuous work and trying and learning, but of learning other mathematical tools and taking different classes. But eventually it does come together, and that's just part of the process. And everybody who learns physics goes through that frustration, that experience